Hi everybody, we are going to cover section 5.1, page 2. So on page 1, we learned how to find the critical points given a graph. Now we want to learn how to find the critical points given an equation. So we're given the function f of x is equal to x cubed minus 12x, and it asks us to locate the stationary and singular points. If you remember, a critical point is just all of the stationary points and all of the singular points put together. So the stationary point is when the derivative is equal to 0. So f prime equals 0, and the singular points is when the derivative is not existent. So f prime does not exist. All right, for both of those, we have to find the derivative. So let's go ahead and do that using the power rule. X cubed becomes 3x squared, and negative 12x becomes 12. So to find the stationary point, we're going to set that derivative equal to 0. So we get 3x squared minus 12 is equal to 0. And to solve that, we're going to add 12 to both sides. So we get 3x squared is equal to 12. Then we can divide both sides by 3. The 3's cancel, so we're left with x squared is equal to 12 divided by 3 is 4. Now we're going to use a property, it's an algebra property. It's called the square root property. It says if x squared is equal to a, we're the ones introducing the square root, so we need that plus or minus. So x would be plus or minus square root of a. Don't forget the plus and minus. All right, so back to our problem. We had x squared is equal to 4. Using that square root property, we get x is equal to plus or minus the square root of 4, which is plus or minus 2. So we found the two x values where we have a stationary point, but the question asked us to answer in coordinates. So to find the y values, we're going to use the original function. And the original function is f of x is equal to x cubed minus 12x. So we'll plug in negative 2, and we'll get negative 2 cubed minus 12 times negative 2, which is negative 8 plus 24 equals 16. So that gives us the point negative 2, 16, because the x value was negative 2 and the y value, the output, was 16. Now for the other x value that we found was 2. We'll plug 2 into the original function to get 2 cubed minus 12 times 2. So we get 8 minus 24, which is negative 16. That gives us the coordinate 2, negative 16. All right, so we found our 2 points that are stationary points. Let's head over and find our singular points, which is where the derivative does not exist. To find where the derivative does not exist, we're going to set the denominator of the derivative equal to 0, because wherever the denominator is 0, the derivative is undefined. In this particular problem, our derivative does not have a denominator. It's just a polynomial. So that tells us we don't have any singular points. All right, so let's go ahead and summarize our answer. We found that we have stationary points at negative 2, 16 and at 2, negative 16. And we also just found that there are no singular points. Cool. So we used an equation. Let's head over to a graph and graph our original equation to see if our answers match up. So on the graph, we have our two stationary points, -2, 16, to -16, and we can see that, yes, the tangent line is really horizontal at those 2 points. We can also see that there are no sharp corners or cusps, which is why we got no singular points when we did our work. So this graph gives us a nice visual to remind us what those numbers that we got in the last slide actually represent.